we have told you that if the leading coefficient of a quadratic polynomial is positive, the function has a minimum value and its curve has a minimum point. Whereas, if the leading coefficient is negative, the function has a maximum value and its curve has a maximum point. But for some reason, you prefer to think that if the leading coefficient is positive, the function should have a maximum value. And if the leading coefficient is negative, the function should have a minimum value. But we don't decide results in science this way. So how is it that a positive leading coefficient indicates that the function has a minimum value rather than a maximum value? Let's look at this. Now, let f of x be as squared plus bs plus c. Then, by the method of completing the square, we can write f of s as a multiplying the expression s plus b on 2a, this expression squared, plus a fraction with numerator 4ac minus b squared, all that on 4a. Let us note that the expression 4ac minus b squared is a constant. It does not involve the variable x. And so it's not responsible for the growth or the decline in the function f of x. If we want to study the growth or decline in the function, we have to examine this first term, the term which involves the x. For a moment, let us denote the expression x plus b on 2a by a new variable t and the constant by a variable s, so that we can write f of x as a t squared plus s. Let's note that this function t squared is a non-negative function. That is, you cannot square any real number and obtain a negative result. The least you can get is 0. So this function has a minimum of 0. So minimum of t squared is 0. This occurs where t equals 0. Again, so because t squared is non-negative, what this means is that as t gets more and more positive or more and more negative, t squared gets more and more positive. So whether t is a very negative value or a very positive value, the square is a very positive value. This is expressed in the following. As t approaches plus or minus infinity, t squared approaches positive infinity. I don't need to put the positive there. Sometimes you put there for emphasis. So now, if a is positive, then as t approaches plus or minus infinity, and we noted earlier that t squared approached positive infinity, and so a t squared is going to approach positive infinity. you multiply a big positive number by a positive constant, you get a huge positive number. And as a t squared approaches positive infinity, a t squared plus a constant has no choice than to also approach positive infinity. So a t squared plus s approaches infinity. But what is a t squared plus s? That is the function. And so we see that in this case, the function does not have a maximum because as x keeps increasing. So one may ask that we have done the analysis in terms of t, but let's look at the relationship between x and t. As s increases, this increases and t will increase. So to speak of t increasing is in place for thinking of what happens when x increases. So we find that the function does not have a maximum, but it has a minimum value. Why? Because the place where the x is, which we've now represented with t, has a minimum value. So this is multiplying an expression which has a minimum value. And so this has a minimum value. It occurs where this is minimum. So a t squared has a minimum value. And if a t squared has a minimum value, then a t squared plus s has no option than to also have a minimum value. We have noted that that is the point where t equals 0. What does the equality of t to 0 mean to x? It means that x plus b over 2a is equal to 0, which implies x is equal to minus b over 2a. So we have the minimum value occurring where x is minus b over 2a. And if x is minus b over 2a, what happens to the function? Let's plug minus b over 2a here and see. So we have minus b over 2a plus b over 2a giving us 0. Then we square 0 to have 0. So all this is 0. And we multiply a by 0. Then all of this is 0. And so we are left with this. And so this expression is the minimum value of the function. This expression is the minimum value. Now the pair minus b over 2a, the ordered pair, so I'll put it in normal bracket, 4ac minus b squared, all on 4a, is the minimum point. A point is a pair of coordinates. So this is the minimum point of the curve of this function. Okay. Now, if a is negative, what will happen? So we continue from here. As t approaches plus or minus infinity, again, we have t squared approaching infinity just as before. But what happens to a t squared? A t squared, unlike in the case where a was positive, does not approach infinity again, positive infinity again. It approaches minus infinity in this case because you have a big value and you are multiplying with a negative number. So you'll be getting negative results. So now, as t approaches plus or minus infinity, t squared approaches infinity, positive infinity, but a t squared approaches minus infinity. And we have a t squared plus s approaching minus infinity. This is just a constant being added. It is added for all the values. So it doesn't stop this train. And so we find that in this case, the function keeps decreasing and decreasing and decreasing, which means that it does not have a minimum value. If you keep decreasing, what comes after is smaller than what comes before, and it continues like that. There is no minimum. However, there is a maximum value. Let's see how that plays out. So now you have t squared being a member of this sequence. Let me put that in a set 0, 1, 2, 3, 4, and so forth, just as an example. And you are multiplying by some negative constant. Let's assume it's -2. What will happen? Here you have 0, then here you have -2, you have -4, you have -6, you have -8, and so on. So you see, after this point, the results you are having are smaller than this one. And so this becomes the maximum. The maximum of t squared, or -2t squared in this case, occurs where t squared is minimum. This is the minimum, 0 is the minimum here, and its corresponding value here, it happens to be 0, but the 0 is not the point. Even if we started from here, we would have had this. This would be the maximum. This is bigger than all the things that are following. So the point is that where t squared was minimum, -2t squared is maximum. So the function indeed has a maximum in the case where the leading coefficient is negative. So at that same point where t squared is minimum, which we know that corresponds to x being equal to -b/2a, what do we find? So now we want to find the maximum value. So we come back and plug it here again. We have 0, 0 times 0. All of this goes to 0 again, and we are left with this. So in this case, we have this same formula giving us, in this case, the maximum value. Maximum value to be 4ac minus b squared, all on 4a. So in this case again, the pair minus b on 2a, 4ac minus b squared, all on 4a, is the maximum point. Is the maximum point. So the formula for minimum or maximum point of a quadratic function is the same. The formula does not tell you that it is a minimum or maximum point. You have to decide that based upon the sign of the leading coefficient.